Right, welcome back to our last review session. Today we're going to talk about agency and incentives, which is a topic that's somewhat related to game theory, maybe a little bit on the little trickier side potentially. Basically, we're going to think about how we can write contracts such that the people that we're contracting with do as we would like them to, even if we cannot necessarily observe what they're actually going to be doing. As I said, this is a last review session, and this sort of wraps up the course. So this might be, as a bit on the trickier side, but I think it's ultimately going to be fine, hopefully. So let's start with the key concept. There is a lot of just basic terminology. Before we get into this, it's really important to keep in mind that all we really try to do here is, as I said, write contracts that make sure that people do as they're supposed to. The kind of setting you should have in mind is one where, say, you're a business owner and you want to hire an employee, and however much money you make really depends on whether the employee works hard or not. You can observe whether they work hard or not, but you can observe how much money the business makes, and thereby you can maybe infer whether they worked hard or not. And trying to figure out how exactly this contract should be structured, namely, what kind of bonus should we pay, what's the base salary that we should be paying. That's something we're trying to sort of develop a concept of today so that you can solve these kinds of problems. In terms of basic terminology, we're always going to talk about principals and agents. These problems are also called principal-agent problems. The principal is the person that hires someone else to do their bidding. So this could be a corporation hiring an employee, say a manager. It could be a business owner hiring, again, an employee, or but it could also be things like a business hiring a consultant, right? Like you can observe what the consultant is doing, but you're paying the money for some sort of service, presumably. These all fit in there. Another one is discretionary investing. If you want to invest money and you give it to an investment professional, they are doing something with their money and that might not be in your best interest. It should be, but it might not be. So like, how do we structure these contracts? With every principal, there is an agent. The agent is really the person who actually does something, and this something that they do is not perfectly observable. Here we, as I said, think about managers, salespeople, employees, consultants, investment advisors. The list goes on and on and on. The real sort of key concept here is that there is something called effort. The agent can work hard or slack off, and it's not possible for the principal to observe whether they're doing one or the other. We only have imperfect signals to tell whether they exerted effort or not. And this is what really makes this problematic, because we don't really know. We would like to say we're only going to pay you if you work hard, but we cannot do that. So in order to get around this, we have to write a contract that hopefully makes them work hard. All of like this unobservable effort gives rise to this agency problem. It's a misalignment of incentives. Whatever the agent would want to do might not necessarily be in the best interest of the principal. So what we have to do is we have to derive or write a contract that aligns these incentives. If we think about this in a practical sense, one way that we get people to work hard in the interest of the company is we pay them bonuses, right? If you think about top management, we give them either options or stock, because that makes their wealth very, very much related to how well the company is doing. If we just pay them a fixed salary, all they're going to do is just put in the minimum effort they can, because they're going to get paid regardless. We're going to talk about two types of contracts. That's basically everything one needs to consider. One is a franchise, where the agent pays a fixed fee to the principal and therefore is allowed to keep all the profits, or something called a salary and bonus type contract, where this is what you're all familiar with. You get a salary, and at the end of the year or day, and we're going to see how that pans out when we're going over an example, you're going to be paid a bonus if times are good, or if you hopefully worked hard, we're going to reward you for it. In order to solve these, and this is something I haven't done in previous years, I think it's very important to talk about backward induction. oftentimes in economics and actually the real world in general, we have problems that have like some sort of either chronological or otherwise logical ordering to them. And solving them from start all the way to the finish is very, very difficult. However, it's usually much, much easier to start from the last step, right? If you want to get from New York to San Francisco, figuring out the entire way is very difficult. But if you think about, well, suppose I already arrived in San Francisco, what's the best place I could be coming from, right? So like, let's think about the last leg of the journey. And once we have that figured out, we can think about like what's the second to last, and so on and so forth. So we're going to start with the easy step, which is the last one, then figure out the rest from there. In this setting with like agency problems, we usually have problems in chronological order. The principal is going to propose a contract. The agent is going to say, I sign it or I don't sign it. And if the contract is signed, then the agent is going to behave optimally based on his own objectives within the constraints of the contract, right? Like they're going to do whatever maximizes their payoff. So when we're going to solve this, we're going to go in reverse. We're going to say, let's suppose we already have the contract and we're not going to specify it any further, and we're just going to derive this as we go. We're going to say, what do we want the agent to do? If we want the agent to work hard, we have to make sure that the margin of revenue of working hard is greater than the marginal cost of working hard. And we can, that gives us one part of the contract that we can figure out. Then we take a step back, we say, well, we know what kind of this last bit of the contract has to be. Now let's think about what do we have to do in order for the agent to accept the contract. Well, for the agent to accept the contract, we have to have the expected pay under the contract to be, must be weekly greater than the outside option, right? The other job that agent could take. And ultimately, we're going to say, well, from the principal's point of view, we just want to maximize profits. So we're going to have a condition floating around which says, well, we have to pay at least this much, and we're just going to pay as little as we can in order to maximize the profits. And ultimately, we usually then have to compute the profits in order to say what kind of contract we're actually coming up with and how much money the principal is going to keep. And you can see why this is called backward induction, right? The way we tackle this, the sort of solution algorithm, goes in exactly the opposite direction from how these events actually would pan out. These are questions that are taken from the ungraded problem set 6 on agency and incentives, and we're just going to go over basically the entire problem set together. We're going to talk about a very sort of standard example of a business owner trying to hire a salesperson. So it says you own a store that you cannot run yourself, right? So you have to hire a well-paid full-time employee, and you cannot run it yourself because you're a well-paid full-time employee, and you're going to hire a probably poorly paid, still full-time employee because you want to keep as much money as possible. The salesperson you can hire on a daily basis, and we know that for the kind of person that we're talking about, we have to pay what they could make at least $100 elsewhere, which means obviously we have to pay them at least $100 in expectation. So we're going to propose a contract to them. The contract must specify how much the salesperson will get paid per day, and we obviously want to maximize the net sales minus the salesperson's compensation. So we want to make as much money for us as we can. And if our proposed contract is not accepted, we're going to get 0. So if the salesperson says that contract sucks, I'm going to get more money if I work elsewhere, I'm just going to leave, then we get 0. Now, the interesting part, and this is currently sort of the basic setting, and we're going to make it more complicated in a later site or in later sample, we have net sales that depend on the effort of the salesperson. So the salesperson can either work hard or not, so we're going to call this effort low and high. If the employee works or doesn't work hard, so exerts low effort, the sales are going to be $125. If they do work hard, net sales are going to be $300. So the contract we can write allows us to make the pay contingent on the sales. We cannot observe the effort the salesperson puts in, but we do see how much is going to be sold at the end of the day. And if we see the number is high, we can sort of infer that effort must have been high, and we can pay a bonus. Effort, on the other end, is not free. So like they incur cost if they exert high effort. In this case, it's $90. So this just captures that working hard sucks and they don't want to do this. So unless there's an expectation $90 that they make by working hard, they're never going to work hard. Or put differently, if we're thinking about sort of willingness to pay and willingness to supply, their willingness to supply high effort is $90. Unless they get that, they're not going to work hard. So the first question then says, suppose that you offer a franchise type contract, so one where they pay us a fixed fee and therefore keep all the proceeds. What would that look like? So what is the upfront fee? If the salesperson accepts such a contract, what effort level will be chosen? Was the value of net sales under such a contract? And what is the daily franchise fee that we can charge? And then we're just going to try to explain whether this contract is optimal or not and whether we can do better. So we're going to follow this exact sort of the procedure that I outlined previously, and we're going to start with the agent's behavior. So we need to start by asking ourselves if the agent is going to work hard under the contract or not. Since at this point we know it's a franchise contract, so they are going to keep everything, comparing marginal revenue to marginal cost is very easy. The marginal revenue of working hard is just like how much more money are they going to keep, right? They've already paid the fee, the franchise fee, so that is a sunk cost. So all that matters to them is the revenue they make from working hard versus the cost. If they work hard, they make an additional $175, right? They get 300 of the total net sales instead of 125. In terms of marginal cost, they incur the effort cost of 90. Since marginal revenue is greater than marginal cost, we know they're going to work hard. That's a given. Now we need to make sure that they accept the contract, right? So how do we do this? Well, we compare the payment under the contract to the outside option. Under the contract, they're going to get the payoff of the day minus the effort cost minus the fee, and that must be weekly greater than the outside option. We know that the payoff of the day is going to be 300 because we know they're going to work hard. So there's no uncertainty in that. Since they're going to work hard, effort cost is 90. And if we rearrange, we just get that the fee must be less than or equal to $110. Since we want to maximize profits from the principal's point of view, we're going to charge the highest fee possible, which is 110. Well, then let's just summarize. This is always a good idea at the end of a question. So under the optimal franchise contract, the agent does exert high effort and pays a fee of $110. The principal's profit is just the fee of, that should say $110. My bad. So second question now says, well, instead of a franchise type contract, we're going to consider a contract with a non-negative base salary and some sort of bonus. And we're going to define a bonus as just like some payment that we're going to make if we see that sales are at X dollars or greater and the payment is going to be Y. And we're going to try to write down a contract with these characteristics of base and bonus that the worker would accept and that would maximize the profits to the principal. And again, since we're asked to explain our answer, we're going to try to be very careful in laying out everything along the way. Again, we're going to start with the agent's behavior. We know that working hard makes sense. Just economically, the marginal revenue or the additional money that can be made from working hard is greater than the cost. So we want to make sure that the marginal revenue is really greater than the marginal cost. How do we do this? Well, we have to make sure that when working hard, the person is going to get wage, bonus, and is going to incur the effort cost. We have to make sure that this is greater than when they're not working hard. In that case, they would only get the wage. Then all we get from this is that the bonus must be at least as great as the effort cost, so the bonus must be $90. And since we're greedy or we want to maximize our own keepings, we're going to say we're going to give exactly 90. We could give more and then things look a little different. You can try that one at home. But we're just going to say we're going to pay 90. Our question is, when should the bonus be paid? Well, only if effort is high, of course. So we're going to say if sales are 300, then we're going to pay a bonus. Otherwise, they would get the bonus unconditionally, and then they would never work hard. Now we have to make sure that the contract is being accepted. So again, wage plus bonus minus effort must be greater than the outside option. If we rearrange, we get the exact same condition, namely that the wage must be at least $100. This is basically just equivalent to the outside option since we're forcing the bonus to be exactly offsetting the effort cost. Again, since we're maximizing the profits to the principal, we're going to say we make this bind. So we're going to pay the lowest possible wage, which is $100. And then so we find the optimal contract, which is one with a base salary of $100 and a bonus of $90 that are paid when sales are high, meaning $300. This is an optimal base and bonus contract. We see that in terms of proceeds to the principal, and again, this should say 110, this is equivalent to the franchise contract. Now, things are going to get a little more interesting. We learned that rather than just depending on salesperson effort, the sales actually can vary from day to day, because days can be good or bad, right? It can be a high demand day or it can be a low demand day. It can be sunny and a lot of people come in, or it can be rainy and no one's going to show up at the store. And none of this is something that we can really observe. That's by assumption. However, what we do know is that these good and bad business days occur with equal probability. And if the employee chooses high effort, net sales are going to be 500 on a good day and 100 on a bad day. And in low effort cases, they're going to be 250 on good days and 0 on bad days. Important here is that the salesperson is going to know whether a day is good or bad when they show up in the morning, right? They can look out the window and see whether the weather is good or bad, or whatever thing they know that we don't. So now we have information asymmetry. They know something that we do not know. We're going to assume they're risk neutral, so they only care about the expected payoff. That's something makes things easier. So now the question is, if we offer again a franchise type contract, and that contract is accepted, what is the effort level going to be on good days, on bad days? What are the expected net sales, and what is the franchise fee that we're going to choose? We're going to do the same thing again. We're going to start with the agent's behavior, and we identify whether they're going to work hard on a given day. Now we have to check for good and bad days separately. On a good day, the margin of revenue of working hard is 250. On a bad day, it's 100, both of which is higher than 90. So they're going to work hard on good and bad days. How do we make sure that they accept the contract? Well, now there's uncertainty. So what matters is the expected payoff. The expected payoff is however much money they make from the business, right? It's a franchise, so they keep everything. Subtract the cost of effort, subtract the fee. Since we have equal probabilities, with a half probability, it's going to be a good day. They're going to make 500, have an effort cost of 90. And then again, a bad day, probability of a half, they make 100 and have effort cost of 90. And from that, they pay the fee, and that must be greater than the outside option of 100. This gives us that $210 minus the fee must be weekly greater than 100. So the fee cannot be greater than $110. Again, we want to maximize profits to the principal, so we charge the maximum fee of $110. And once again, we have a franchise type contract, which gives us basically the exact same solution as the previous one. Note here, since we're giving basically all control rights, or the entire decision authority about whether to work hard or not, to the agent, this is efficient. So the agent is the more informed entity here. They know more than we do, and generally speaking, it is always better to give as much power as possible to the entity that faces the uncertainty, rather than trying to design a contract to get around this. Now in the last step, and this is the really interesting and probably hardest one, we're going to suppose that instead of writing a franchise type contract, we have to again have a non-negative base salary and a bonus. And again, the bonus can only depend on one number, namely what sales are. And we're going to try to write this down and see how good we can do. Just as to get the numbers, remember that on good days, sales can either be 500 if they work hard or 250 if they don't, and on bad days, it's 100 and 0. Let's start with the agent's behavior. So the question is, how do we set the bonus? From before, we already know the bonus must be 90 because it must be exactly offsetting the cost of effort. So we don't need to check that again. Now there are two options. We can either say we're going to set the bonus at 100 or at 500. If we say, or sorry, not dollars, but like if we see sales of that or above, we're going to pay. So if we set the bonus to be paid if sales are 500, we're going to get high effort on good days. This should be intuitive, right? On a good day, 500 is attainable. On a bad day, it isn't. So, meaning on a bad day, they're never going to get the bonus, so they're never going to work hard. But if we say the bonus is going to be paid if we see sales of 100, on good days, it's always going to be above 100. So they're never going to work hard on good days, only on bad days. So we cannot get both. We cannot get hard work or high effort on both days. So what do we want? To figure that one out, we just have to say, since we're basically keeping the rest, right? We have to check how much value there is being created on a good day or on a bad day based on high effort. So we're just going to compare on a good day, effort creates additional $250, and bad day it's just an additional 100. So we clearly want high effort on good days, so we're going to pay the bonus if we see sales of 500. Now, we need to ensure that they accept the contract. Again, we're just going to take the expected payment they get. That's the bonus, the wage, minus the cost of effort. Equal probabilities again. So on a good day, it's whatever bonus they get on a good day minus the cost of effort. On a bad day, it's the same, plus the wage. On a good day, they're going to work hard. We established that. We're going to pay them $90. On a bad day, they're not going to work hard. We're not going to pay a bonus. And they get the wage. And again, we get that the wage must be weekly greater than 100. Now we know the bonus is 90, the wage must be at least 100. Since we want to maximize payoffs to the principal, we're going to set the base wage to $100. And so the optimal contract now is one in which we set a base of 100, a bonus of 90, and this to the principal is going to generate a total profit of just the expectation of sales minus wage minus bonus. On good days, sales are going to be 500. We're going to pay $90 in bonus, $100 in wages. On a bad day, sales are going to be 0. We're going to still pay $100 since this is a base salary. So an expectation we have $105. So this is less than under the franchise. Again, showing when there's uncertainty involved, it's easiest in order to get the best possible outcome to just basically assign as much power as possible to the agent. And mind you, this is also optimal from the business owner's point of view, right? Because since the franchise contract, they're still going to get paid, and they're going to actually end up getting more money, 110 instead of 105 under the franchise, because we can get high effort on both days, which we cannot possibly get with this sort of base and bonus contract. This was problem set 6. This was a quick one. I hope that it made sense, and good luck on the exam.